In the final part of the lecture sequence, I'm going to show you a fun little demo. Okay, in this demo, I'm going to use a AND gate like the ones you've seen before and apply some inputs to it in a fun manner and at the same time superimpose some noise on one of the signals. So for example, what I might do is take a noisy signal, take some noise and add that to the Y input. And if you really believe in all that we've done so far, then even if noise is added to the signal on Y, then the output of this gate might still be pristine despite the noise on the Y input, because this gate is adhering to the static discipline. Okay, if the gate is correctly interpreting its output low and output high voltages, then the output must be correct, even if the inputs are noisy, provided, of course, the inputs adhere to the static discipline. So let's take a look. So I'm going to apply a signal X that looks as follows. And I'm going to apply a signal Y that looks a little bit different, like so. And so you would expect that the output Z is going to look like this. So my output is going to be a ANDing of the two inputs. So not surprisingly, notice that starting at this point, both X and Y are a 1. So Z is going to a 1. And then at this point, X goes to a 0 while Y stays at 1. So therefore, Z pops down to a 0 and then stays at 0 until both X and Y go back up to a 1. Okay, so this is pretty much similar to what we did earlier, and this is the signal that I expect to see. Now, when I inject noise into the system, then what is going to happen is that the signal Y is going to have some noise superimposed on it, and what you're going to see is that even with the noise superimposed on the signal, my output is going to stay pristine because of the static discipline. Of course, if the noise is so much, so large that it begins to overwhelm the gate, if the gate is not designed to handle the noise, then things will go haywire. But provided the noise is within the noise margin, then my gate should work correctly. Okay? Watch and have some fun.